Welcome to PreMath. In this video, we have got this red shaded square DEFG fully inscribed in a right triangle ABC, as you can see in this diagram, such that this side length AB of this triangle is 9 units, whereas this side length BC is 18 units. And now our task is to calculate the area of this red shaded square DEFG. Please don't forget to give a thumbs up and subscribe. Please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. Let's focus on this right triangle ABC, whose side lengths are 9 and 18. And now we are going to calculate its third side length AC. So therefore we are going to use the Pythagorean theorem. And here's our Pythagorean theorem: a square plus b square equal to c square. Let me go ahead and call this longest leg as our side C. I'm going to call this side lowercase a and this lowercase b. So let's go ahead and fill in the blanks in this Pythagorean formula. A in our case is 9. So this is going to become 9 square plus b is 18 whole square equal to c square. Let me go ahead and manipulate this 18 square. 18 square could be written as 9 times 2 whole square, which is same as 9 square times 2 square. As you can see in this next step, now we can see 9 square is in common. So therefore I can factor out 9 square outside, and we are left with 1 plus 2 square equal to c square. And now we can see 2 square is 4. 4 plus 1 is going to give us 5. So therefore this whole thing is going to become 9 square times 5 equal to c square. Now let's go ahead and undo this square. So I'm going to take the square root on this side and on this side as well. And we can see this square and square root is gone. So therefore c turns out to be equal to, here square root is gone for this 9. So I can write 9 outside times square root of 5. So this is our c value. So thus our this AC length turns out to be 9 times square root of 5 units. And here's our next step. Let's assume that alpha and beta are our two complementary angles. In other words, sum of these two angles must be equal to 90 degrees. Now let's assume that this angle is alpha. We know this is our 90 degree angle. Then in this triangle ABC, this angle has got to be our angle beta. And now let's focus on this triangle ADG. We know this is our 90 degree angle. This is our angle alpha. Then this angle has got to be angle beta. And finally, let's focus on this another right triangle CEF. We know that this angle is 90 degrees. This angle is beta. So therefore, this angle has got to be our angle alpha. So therefore we conclude that this right triangle ADG is similar to another triangle ABC according to angle similarity theorem. So therefore we are going to have a proportion. Let me go ahead and write down the ratio of AD and DG. Let me go ahead and write down AD divided by DG is going to be equal to the ratio of this side AB and BC. Let me go ahead and write down AB divided by BC. And we know our AB length is 9 and BC length is 18. So therefore we can write AD divided by DG equals to 9 divided by 18. And we can see 9 divided by 18 can be reduced to 1 divided by 2. So therefore I can write AD divided by DG is equal to 1 divided by 2. And now we can see, we can write AD equals to 1 times some constant K, and likewise DG could be written as 2 times some constant K. So therefore our this length AD is 1 times K, and this DG length is 2 times K. And now let's make an observation. We can see that we are dealing with this red shaded square DEFG. That means all side lengths are going to be equal. If this side length is 2 times K, this is going to be 2K, 2K, and likewise this one is 2K as well. And likewise we can see that this other right triangle CEF is similar to this bigger right triangle ABC according to angle similarity theorem. So therefore we are going to have a proportion. We can write the ratio of EF and EC. So let me write down EF divided by EC is going to be equal to the ratio of AB and BC. Let me go ahead and write down AB divided by BC. And now we can see our AB length is 9 and BC length is 18. And once again, this could be reduced to 1 divided by 2. So therefore, we got a ratio of EF and EC is going to be equal to 1 over 2. In other words, the ratio of EF and EC is 1 to 2. If this side length is 2K, then this EC length is going to be 4 times K. And now let's make an observation. We can see this segment AD length is 1K, this DE length is 2K, and this EC length is 4K. So therefore this total AC length is going to be, I'm going to add all these individual lengths. 1K plus 2K plus 4K is going to become 7 times K. So therefore we can see that our this AC length turns out to be 7 times K, but we also know that our AC length is 9 times square root of 5. So therefore I can equate 7 times K equals to 9 times square root of 5. Let's divide both sides by 7 to isolate K. So therefore our K value turns out to be 9 times square root of 5 divided by 7. And we know that side length of this red square is 2 times K, and our K value is 9 times square root of 5 divided by 7. So therefore I can write this one 2 times 9 times square root of 5 divided by 7 over here. So therefore the side length of this red square is going to become 18 times square root of 5 divided by 7 units. And here's our final step. Let's go ahead and calculate the area of this red shaded square DEFG. And now let's recall the area of a square formula. Area equal to S square, where S represents the side length of the square. And in our case, the side length of this red square is 18 times square root of 5 divided by 7. So therefore the area of this red shaded square is going to be, I'm going to square this 18 times square root of 5 divided by 7 whole square. So if we simplify, that is going to give us 324 times 5 divided by 49. And if we simplify furthermore, the area of this red square is going to be approximately equal to 33.1 square units. So thus the area of this red shaded square turns out to be 33.1 square units. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.